Hello and welcome to another session in mathematics. In this session, our topic will be integration. But before that, let us take a review of our previous lesson. Welcome back. In the course of this study, we'll be looking at integration as anti-differentiation, and then we'll look at some standard basic integration. Okay, let us start. Integration as anti-differentiation. Integration as anti-differentiation. When we are dealing with differentiation, if we are given y to be equal to x raised to power 2, we differentiate this with respect to s to be equal to what? 2x, right? But under integration, if we are given y to be equal to x raised to power 2, then it means that y is equal to the integral of x raised to power 2. Then we have dx. Okay, and then if we integrate this, we then have x raised to power 2 plus 1 all over 2 plus 1 plus c. Okay, and that will give us x raised to power 3 all over 3 plus what? C. And that's just the answer. Okay, so the term integration is just the anti differentiation that we just did. In differentiation, we subtract 1 from the power, but in integration, we add 1 and still bring down the power to divide what? The given equation. Do we understand now? So we say that integration is what? The anti-differentiation. Integration is anti-differentiation. Okay, let's take some examples on integration. Number 1, let's integrate x raised to power 3 dx. Okay, to integrate this, we first of all remove what? The integral sign, and then we have x raised to power 3 plus 1 all over 3 plus 1, then plus what? C. Where c here is what? Constant. C means what? Constant. And this is equal to 3 plus 1 will give us x raised to power 4 all over what? 3 plus 1 will have 4 plus c. And that's just as simple as that. Okay, then for number 2, if we have the integral of 1 over x squared dx, all we need to do is to make this to be what? Of the form x raised to power minus 2, law of negative index, where if we have x a raised to power minus x is the same thing as 1 over a raised to power what? X. So if I apply that knowledge here, it means that x raised to power 2 is the same thing as 1 over x raised to power what? 2. So therefore, this is equal to the integral of x raised to power what? Minus 2. Then add your what? Dx. So by integrating this now, we have x raised to power minus 2 plus 1 all over minus 2 plus 1 plus what? Our c. Okay, so we have x minus 2 plus 1 will give us what? Minus 1 all over what? Minus 1. True of us. Then plus our c. Don't forget this c. Okay, we cannot leave it like this. So what do? Remember that x raised to power minus 1 is something as 1 over x, right? Then all over our minus 1. Is that right? So this is equal to 1 over x times minus 1 over 1. And that will give us minus 1 times 1 will give us minus 1 all over x times 1 is x, then plus our what? C. And that becomes our answer. Okay, so you see how simple integration can be. So let us look at some standard basic integrations. Standard basic integrations. Okay, these are some integrations that you do not need to solve because they are already solved, and their result is what I'm giving to you right now. So if you are given, for instance, the integral of x raised to power n dx, for you to integrate, this is just equal to x raised to power n plus 1 all over n plus 1 then plus what? C. It's important you note that n is not equal to minus 1. Okay, the n here is not equal to what? Minus 1. Do you understand? Okay, so number 2, if we are given the integral of 1 over x dx, this is equal to what? Log s plus c. If we are given the integral of exponent x then dx is equal to what? Exponent x plus c. The integral of exponent kx dx is equal to exponent kx all over k plus c. Remember, k here is what? Is a constant. Then 5, if we have the integral of sin x dx, sin x is equal to minus cos x plus what? C. Remember, in differentiation, if we differentiate sine, we get what? Cos x. But here, if you differentiate sin x, you have what? Minus cos x. For 6, the integral of cos x dx is equal to sin x plus c. In differentiation, if we differentiate cos x, we have minus sin x. But here there is no minus, there is just what? Sin x. Okay. 7, if we have integral of sec squared x dx is equal to what? Tan x plus c. Okay, so I just want to stop here. You can read up the remaining in your textbook. So this is the basic you need to know about integration. Then in our next class, we'll then go over to the rules of integration. So to refresh your memory of what we've just done, kindly provide the answer to the following questions on the screen. Welcome back. Do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your questions or comments on the comment section. Till we meet again, stay safe and bye.